I want to get right into our discussion here. You should see on the presentation there, you see my balding head. I'm Greg Tinker. I'm the Chief Technology Officer for SereneIT. My former background, most people know me as one of the Tinker twins out of HP Engineering, and I spent most of my career there at 17 years. Since then, now I'm a founder and run a large IT engineering firm known as, again, SereneIT. We work in the Fortune 50 space and the small, medium business, or I would call it large commercial space, and we write a lot of automation for our clients. And what do we automate? We automate the core data center. The data center of block storage, NAS storage, networking, firewalls, all up the stack. Today's topic, though, is what we do in the software-defined block arena, and I'm very excited to have that discussion because it's one of my big passions. Some of our largest customers are large pharmaceuticals and manufacturing and financial firms that hold tens of thousands of servers, and we're going to show you how we can take servers and give you a new way of thinking about how to do that today. So again, thank you for your feedback. Greatly appreciate that. And I won't use any more surveys because they appear not to be working, and we'll take care of that later. So we can fix a lot of things. I can't fix everything on the fly. All right, so with that, let's get started right into this puppy. So what I'm going to do here is next slide up, and I have in our engineering lab room, we have a large conference room, which you see me sitting in, and we have multiple displays up on the monitor. So you'll see my eyes shift from one display to the next. We have multiple displays up here, and it helps me keep track of the talking points. On this screen over here to my right, you'll see my eyes shift. We are outlined today. I'll do my best to keep focused on the camera, so it gives us that nice direct line of communication, and I'm, again, glad that you all attended today. So again, the talking points. Who are we? What are we discussing today? Software-defined block. What does SereneIT do to make it better? We'll talk about automation, our consulting practice, and success stories that we've had around the world. We'll leave it or end the session with Q&A, but I do encourage you at any moment during this conversation, don't be afraid to unmute and ask a question, or we have multiple moderators monitoring the chat session, and they will be happy to interrupt me and say, we have a question. So don't be afraid to ask. So let's start with who SereneIT is. SereneIT is an IT engineering firm. We are also a VAR, a value-added reseller. We are a next-generation IT engineering firm. We hold multiple patents. Our company has grown rapidly over the last several years because we are focused on the pain points of modern IT ecosystem. In fact, COVID-19 has actually expedited our growth. The work at home models, the large scale VDI deployments, things like that, that require a lot of human interaction to make the systems work at scale, has really put a huge demand on streamlined automation process, playbook manipulation to be able to deliver this stuff at scale. And quite frankly, that's our powerhouse. And in fact, we hold, again, multiple patents in this space. This kind of gives you a high level of who we are. I'm not going to go into this. You guys can read it a little bit later. But what we want to bring to our clients, small to enterprise, is a way to bring a modern ecosystem of IT and make it easy to manage. In fact, give you that serene experience. So today, we're talking about software-defined block. And I love this photograph. For those that work in the enterprise space, you're always at some point, be it ransomware, be it growth, running out of capacity, can't get the performance you need at the time you need it. People are constantly barking at you to get things working faster. In this day and age, it's instant delivery. You click it, you expect the results. No different. You pick up a phone and you listen to a dial tone. You just expect it's table stakes. It's got to work. All right, probably my kids don't even know what a dial tone is. Everybody's used to these. There's no dial tone. But anyway, it's a good analogy for those of us that actually remember the dial tone. Anyway, so the defined data center has to focus on, looking at the virtualization space, the control of data, giving you high-end performance, low latency, and be able to understand the HSM layer. For those that don't know the HSM concept, hierarchical storage management. I need to keep some high performant, some medium, some low, and some just extraordinarily slow, archival, public cloud. And we'll go into that. So the thing that you step back and you look at on a storage platform, we focus on Datera. And I'll go into more about Datera later. It's in my book, it's probably one of the best software-defined block storage platforms on the market. There is another product out there, and I'm not being disparaging on this. It's a good product. You know, people know it as Scale.io. It's been renamed 2 times since. I think it used to be called VFlex. Now it's called PowerFlex. You don't quote me on this. There's, of course, the old school guys that know Cinder, going into OpenStack, going into iSCSI concepts. And I can go into that. We do a lot of that. I call that Frankenmonster, meaning you're building a custom OpenStack structure that very few people on the planet can manage. Those are good and they have their place. And I have noise on the backdrop. Thank you very much for muting. So those are great in certain universities and in areas of academia where you're studying or trying to keep costs low and have students build that out. That's great. But in the enterprise or large scale commercial, you don't want to do that because the number of people that can support it are just a few handfuls. You need to model a product that can be sustained and supported at scale. So there's a few on the table. And we prefer, again, Datera, and I'm going to go into why, and it's because of the automation side component, the RESTful API, the integration of all that stuff, and we'll get into that in a moment. But when you step back and you look at your the data center, the dynamics, and all the things of a data center today, data automation, high availability, understanding low latency, NVMe, talking about remote RDMA channel communication, and most people don't know what that stuff is. It's when you're doing I/O to an array. I don't want to pull off the spindle. Even solid state or flash, I don't want to pull off that. I want to pull off NVMe. I want to be right next to the CPU and pull that data out. We can do that today. And we do that in a software-defined block store. Do we have that in a traditional block storage environment? Yes. Is it very expensive? Yes. Is it right for everybody? No. There are times and places where a traditional block store works perfectly for somebody, especially if it's a legacy fiber channel shop. But in a modern ecosystem, you have a model where you can do a software-defined block storage, iSCSI base that is more than adequate for anything you're doing in the business. And you don't always need a block store or a traditional block store. So you need to make sure that when I'm pointing over here, because you see it on your screen, the software-defined data center awareness, having RESTful API integration, being able to look at telemetry data. What do you mean telemetry data? I'm burning out my hard drives, solid state. They're not infinite, guys. You can't read them forever. You'll burn out the cells. So when you do the right ratio, you have what's called a wear gauge on the SSD layer. You need to make sure that your software can understand that wear gauge from the bare metal. That's why we also choose HP servers. From the bare metal layer all the way up to the software stack. This is table stakes in a traditional appliance, like a Primera, 3PAR, these type of block arrays, the EMC arrays, Dell arrays. That's kind of table stakes. In a software-defined ecosystem, though, the software, like a Datera, has to be able to have the hooks in to the hardware layer to pull that telemetry data out. And you want to make sure that your software has that. We actually automate that. Now, it's kind of like BASF of yesteryear. We don't make a lot of things you buy. We make a lot of things you buy better. That's SereneIT. We look for the best in breed technologies that close that gap as much as they can. And then we automate on top of it to keep our costs low and give a better user experience to our clients. So that's what this slide here is talking about, is giving, being aware of all the columns that I've mentioned up on top, continuous tech adoption, modern ecosystems, data services platform, persistent memory, NVMe, going into a hybrid technology, going into the cloud, being able to have a single apparatus, be able to go into multiple hooks at any given time, and all of that sitting down on hardware that you trust. I've listed all the vendors out here. We choose HP. but other vendors, other customers may choose others, and that's okay. But we choose the best in breed, and we'll go into more details of that. And some people think of it like Ford and Chevy, but there are differences, and it's important to know those differences and at least have an open discussion. And just know that when we discuss it with you, we'll show you what we believe to be the best and why, and then you guys can make the decision as the client. And now, let's step back for a moment. I talked about a high level there. I'm going to go a little bit deeper. On the next few slides, I'm going to continue to drive deep and explain in more detail what I'm talking about. Again, software-defined block. What does that mean, software-defined block? Take a traditional block array, be it an EMC array. Maybe you're a VMAX shop. Maybe you're a Dell shop. Maybe you're an HP shop, 3PAR, EVAs. That's old school, but hopefully you got something newer than that. Anyway, so you got the traditional block, and then now you're going into this modern ecosystem of a software-defined block store. What does that mean, software-defined block? It's iSCSI. Can it be other stuff? Yes, sir. It can be ISER. You'll see that. ISER that basically is iSCSI remote RDMA channel structures. For those, again, that don't know what that is, it's where I can actually issue a command to go across the Ethernet wire and pull pull data right out of a RDMA channel, or a direct memory access is what it boils down to. I don't have to go down to the spindle. It's very important to understand that. And that's how we deliver high-speed store. You don't need fiber channel anymore. That's 5 years ago. I know that doesn't sound very long. My kids would probably say that's an eternity ago, Dad. I don't know anything about that. But I tell you, today, the iSCSI block stores are faster than any of the fiber channel stuff. Fiber channel maxes out at 32 gig. We're running Ethernet over 200 gigabits a second. So just letting you know, in the lab, it's over 400 gig. It's crazy fast. Ethernet is where it's going. Why? It's cheaper. It's blunt. It's cheaper. S3, object store, any type of software-defined solution, we have our favorites. Like if you're looking at NAS products, you're looking at software-defined rack top. Most solutions out there on the planet they have their core competency and also can. Just like in most object software-defined blocks, they can also do S3. Or they can also do NAS, but their core competency is block. So you got to know what your business case is and understand that business case to make sure you choose the right technology. At the end of the day, though, we're running on, the software-defined ecosystem is having servers. In this case, I'm showing DL servers. These are HP DLs with Optane memory, Intel processors. You have that on the lower end, on the hardware layer. And on the top right-hand side of this picture, what I'm depicting here is basically a simple way of taking multiple servers. Maybe they're HP, maybe there's something else. We choose HP, and there's reasons for this. Maybe you have your servers there, and then you tie that, your Ethernet cables back into, I like Mellanox switches. Cisco's and others are great switches. Mellanox, though, is what I call, they're more like if you're a brocade man or a brocade woman, maybe I should be gender agnostic. If you are a fiber channel legacy person that loves fiber channel, loves the fact that you got an A and B fabric, then Mellanox is where you need to be. I love Mellanox for that purpose. It's a storage-based, high-performant 100 gig, 200 gig Ethernet switch. And now you have two of them. You have a single management interface, which you have two separate switches. And it's dedicated for storage. Don't confuse it and think you're going to plug a laptop into it. That's not what it's for. You treat it just like you do fiber channel. You have your storage backend network, and you have your outbound facing server Ethernet network. They are two different connections, just like your fiber channel network is today. Okay, so again, having that way to manage that and having different protocols and the platform layers, right? The bare metal, the virtual machines, containers, Docker, Kubernetes tied right into it. And that kind of comes back to, so once you have that understanding of what technology you want, maybe you just want block, maybe you want S3, maybe you want a different type of servers, maybe you, and as I mentioned earlier, you got different types of servers in there. And when you choose these different types of servers, and I'll back up 2 slides here, it's important to understand some of those servers 80% of them do not have detailed telemetry data inhooks in the actual microcode because they don't actually all write their own microcode structures. And there's reasons for this. You're not able to pull out the actual latency on the RDMA channels like we can on some of the higher end gear, like the HP gear. We can actually see when we're actually running out the runway buses on the CPU tied into the memory ranks. Can't do that on all hardware. Almost all hardware you can't do that on, but you can on HP. And that's why we take our RESTful API structures and we're actually monitoring that data flow on the backend chassis. So, when you're looking at that data, you have to have a platform. Otherwise, you got to start from zero, right? You got to write, okay, just because you can do I can write this, our engineering team can write the C code to go in and pull the telemetry data out of the BIOS. Let's just say we can, and most hardware we can. Now we got to actually put it into an apparatus so you can look at it. Oh, I am running too many mutex locks. I am running too many hard interrupt controls. I am burning my CPUs on X. Maybe it's too much encryption. Maybe compression is set too hard and you're in user space, burning up 9 cores of your 12-core socket. Are you aware of that? Maybe, maybe not. Most people aren't. That's okay. That's why companies like us exist, is so we can go in there and fine tune it, know which knob to turn, button to push, lever to pull. That's what an engineering team does. So we sit down and make sure we can tune the system to run at high performance, which is what the end users want. We can break it down if you're looking at, maybe you're an XP shop, and I'm actually using HP terms here because I know those best. I came out of HP engineering, but quite frankly, if it's 3, 4 Vmaxes, name your favorite out there, we do this on all platforms. So we're platform agnostic when it comes to our engineering talent. But my point of that story is, when you look for a software-defined block, you're looking at a scale-out structure, not a scale-up structure. Block traditional stores are scale-up, like the XP, the 3PAR, the Nimbles, the MSAs. You buy it and you just add more disk shelves to it. No more controllers. You got 2 controllers. The XP probably is a minor exception to that, right? You got your channel adapters. For those that don't know what that is, that's basically another controller, and you just add in another channel adapter at $250,000 a pair. Pretty expensive. But there's a time and place for those, okay? We run those in large-scale financials, Fortune 50 companies that have 1 million users on it, right? There's a time and place for that gear. Is it for everybody? Cabinet shop in Alabama? Not really. I've seen one there, though. That's a whole nother discussion. Anyway, I just want to make sure that you guys understand there's a time and place for the hardware, and it's best to have a conversation to make sure that you choose the right solution to grow your business and keep the financials or the fiscal responsibility to achieve the objective of the base, to get your ROI and grow your business. And you got to make sure that, and I've listed out here on the right-hand side here, making sure that you have a good, easy, automated structure to be able to expand volumes, create volumes, tie volumes into your orchestration engine. Maybe you're a VMware shop, KVM, Hyper-V, name your favorite, right? And you want to deploy a SQL server. That's what we do. Push the easy button. Within 10 minutes, our team has our entire data center, and we have enormous amount of systems. We have petabytes of data in our private cloud. SereneIT is a MSP company as well. And I say that because our automation that we have developed for the biggest companies in the country and the world, we have customers in Singapore, UK, all the way across the Atlantic. I say that because the automation we do for them, we do in our own data center. And that's how we're able to grow at the rate we're growing. We're not a body shop. We're an automation shop. And that's allowing us to grow an enormous amount of systems so quickly. We monitor and manage everything automatically. So I'll go into more details about that later. All right, so stepping back. So you need to make sure that when you're looking at a solution, be a software-defined ecosystem, that we're able to tie into any type of cloud. And in this demonstration here, we want to make sure that we are hardware agnostic. We all have our favorites, right? Some people are Dodge. I have a Dodge truck. Some people are Chevys. That's my dad. Some people are Ford. That's our director of engineering. He loves Ford. So anyway, everybody has their favorites. I want to set that aside. I want to say, don't necessarily focus on the hardware. Focus on what the business outcome is. What is it that we're after? And then our engineering team will take the business outcome you're achieving and make the right technology choice to help you get there quicker and with good financial constraints so that we don't blow the bank trying to achieve an objective. We can always put a Maserati in there, but do we need one? Anyway, all right, so understanding on the software-defined block storage, knowing whether you need, S3 object, maybe you need a little bit of NAS, maybe you need all block high performant, maybe you don't need high performant. Maybe everything you need in 200 microseconds. We have clients that need 200 microseconds max. For those who don't know, 200 microseconds takes 1,000 microseconds to make a millisecond. The human eye blinks in 300 milliseconds. We're talking microsecond latency. You wouldn't even notice it. Anyway, so there's a future fact there for those, or fun fact, I should say. So let's go into, now that I've kind of laid the groundwork for a software-defined ecosystem and leveraging a apparatus to give iSCSI out storage on server compute, let's talk a little bit about how we automate it. We are an Ansible shop. We write about 85% of our automation is in Ansible. That does not mean we can't use Puppet, Chef, or SaltStack. I don't show SaltStack on this list. Quite frankly, we just don't. We can. There's nobody. We don't run into SaltStack much. I mean, I don't mean to be disparaging about it. We just don't see it a whole lot. We use SaltStack in our own data center, but well, that's where we use it. All right. So from an engineering perspective, you need to make sure that you choose a company that can bring true value and not just push paper. That's really what our message is. And as we continue to go into these discussions with our clients, we're focused on the entire ecosystem. In this case, we're talking about the entire ecosystem of automation. Wouldn't it be nice that if you want to deploy a new SQL Server for a business unit, maybe you have a department, so you're a big company, 1,000 employees, and you have a department that wants to do a new SQL deployment for whatever reason, maybe it's test and dev, doesn't matter. Wouldn't it be nice to be able to have a self-service menu where they can choose SQL Server, small, medium, or large? What type of storage do you want? Block or NAS? Most people won't know that. So when we write our automation, we actually talk to the customer and say, does your end user understand the difference between a block store and a NAS store? 9 times out of 10, they don't. So what we do in our automation is we actually give them the pull down menu, high performant, moderate, or low. You choose 3. Almost everybody chooses high, just so you know. So we always put a $ next to it and we make it simple, just like the OpenTable app. Those who use OpenTable. I mean, I pretty much everybody on here uses OpenTable, right? You go to do a reservation. Okay, I admit with COVID, reservations are kind of down. But you choose a dollar amount. You look at the restaurant. How many $ is it? 2, 3? Is it $5? May not choose that one tonight for dinner, right? That's a self-service portal. We give that same benefit to our clients. So when we deploy that SQL Server, we literally spin up the storage. We have safety logic. Most of our time in our development is not delivering the code. Let me give you an example. Deploy SQL Server. It takes our team maybe a day to write all the automation to take a template and take a SQL Server and deploy that out on data store. I'm talking about take the storage array, deploy the LUN, tie it into your hypervisor, KVM, Hyper-V, it doesn't matter. You take that hypervisor, you add that data store, put that VM on it, look at the entire cluster, which one has compute available, we'll put it there. Oh, you want to DR it, we'll replicate it over to another facility. We'll do all that. That doesn't take us that long to do that. What takes us a long time is writing the safety logic. Do you have enough storage? Maybe you do, maybe you don't. Maybe you have enough storage, but you don't have enough performance on that array. You've already tapped it out. Maybe it's a 3-node software-defined block storage. Maybe it's an 18-node software-defined block storage. Which one has the performance? Maybe it does, maybe it doesn't. Safety logic has to be written. We do that. We're able to break that down and show it, and that's what we're doing in the enterprise scales today. We're doing that for our large-scale customers so that when they deploy a software-defined block, be it a 3-node or an 18-node or bigger cluster, we look at the telemetry data to figure out, hey, how much load is on it so that we can make a good educated choice of which cluster to sit it on. That goes into, why do we have multiple clusters? Fault domains. Do you want to put all your eggs in one basket? I'm a huge guy on fault domains. Love fault domains. Even in our core data center, we have 4 fault domains. We even deploy a red forest. It's a hybrid red forest. It's not really a red forest. For those that don't know red forest, it's where you actually have a very secure domain structure. So if you were to have a hacker hit a domain, it won't hit the actual management domain, which is a blind hidden domain. Very, very secure. You can Google it. Just Google red forest. Red forest domain. That's probably the best way to Google that. All right, anyway, continuing on here. So making sure you have the right policies in the control plane. All that's done via REST API. We're an Ansible shop in Terraform. So Terraform is how we actually manipulate the hardware. You just take a server, plug it into a rack, plug up power, plug up the ILO or iDRAC, or name your favorite, whatever the lights out management is of your platform. We do them all. Take that platform, and then we use Terraform to control the hardware layer. Once it gets to hardware layer and we deploy the OS and boot up the OS kernel structure, then our Ansible tower is taking over, and then we're managing the actual application to deliver the end result into the orchestration engine. We wrap all that up with a nice CMP. For those that don't know that term, that means Cloud Management Platform. We have another webinar on that. We'll get to that later. So that's what we are passionate about, and that's really the differentiator of an IT engineering firm that's a VAR versus the traditional VARs that most people are familiar with that just push paper. We want to bring value to our customers so that they see the difference in how we can take a technology and make it better. Our tagline is almost identical to that of BASF in the 80s for those of my generation that know it. We don't make a lot of things you buy, we make a lot of things you buy better. One of my favorite taglines. It's hard for us to invent everything. We don't do that. We have multiple patents in this space. That doesn't mean we developed Datera. That doesn't mean we developed the HP servers. It means we take those best-in-class, best-in-breed technologies, and we give a better user experience with modern data center automation. So the next slide up is talking about that full automation structures. Not only do we manage the hardware and the hypervisor layer, for those that are starting to embark on the new journey of Docker or containers, Kubernetes, we do that inside and out. And why is it important to have a best-in-breed software-defined block store that is already integrated into that? Knowing it's the REST API callouts, it's the self-service portal structure, having the availability to be able to tie into that. Having the framework engine that exists, Datera has that. And since they have the framework, our level of automation engineering work required to get a better ROI is greatly reduced. We have one platform, and I won't mention the vendor. There's only so many software-defined block stores out there. Took us well over a year to get what we could do with the Datera framework in just a few months. Big difference. We were able to make it work in a few weeks. We had to write the safety logic so the customer didn't fall off the edge of the cliff. That took us a few months to write all the safety logic so that they can't get themselves into a bad situation. Remember, big difference in, can I make the automation work? Yes. A lot of people can do that. How many people can actually write all the safety logic so that you don't fall off into the ravine? Very few people do that. That's what we do. So, rebalancing continuation work stuff. Let me take a moment here and talk about something simple, a simple bare metal upgrade that we've done for this structure. So in our playbook structure, and this is an Ansible and Terraform example. We're using both Terraform and Ansible to control the hardware layer. And this is a framework. This is where we hold one of our patents. And there's nothing here that's intellectual property that really would you could take from our patent in this space. So this is a high-level diagram. In this high-level diagram, what we're trying to articulate is the fact that we can take any server, bare metal server, and maybe it's a software-defined block, maybe you're using OpenStack, maybe you're using Cinder, maybe you're using Scale IO, today called PowerFlex. I think it's called PowerFlex today. They've rebranded it a few times. Or you use Datera, my favorite. When you take in these software stacks, you got to manage it from the physical layer all the way up. So what we have done is we actually, and this is where our patent sits, is we have automated managing that bare metal layer. Don't care, agnostic. Bare metal layer, that's the drivers, the patches, the firmware, all that fun stuff. And then you go up to the operating kernel layer, in this case, like a Datera, and we patch the Datera node, but it's easy to patch a Datera node, right? Or any node for that matter, ESX, Hyper-V, KVM, this goes on, bare metal machine. It's all easy. No, it's not. What do you got to know? Safety logic. Can you take that node offline? Do you have high availability? What is it, a rack, redundant array of compute? Is it an active passive cluster like server scarred? You got to fail the cluster structure over. You got to know what's running on it. We have the playbooks. We've written the automation for that. We pretty much run on any operating system that exists, other than mainframe. We don't do mainframe. We can do mainframe. It's just not a big calling for us. So we take that and we actually will check all that and then take that system into what's known as a maintenance mode. Most of you are VMware, you know what maintenance mode is. We use that same concept on every platform. And then once it's in maintenance mode, that's when we take control and do what we need to do to that system. And then once it's back out of maintenance mode, bring it back into the cluster and continue down the line. Wouldn't it be nice if all you had to do is push a button and all that happened? We got reference accounts of some of the biggest companies on the planet. That's what we do. This is a Agile DevOps model of how we actually do it. Again, big differential is the fact that we can take a infrastructure, server compute, turn that into a block store with Datera, and then give you a cool software-defined ecosystem for the future. Now, does that mean software-defined block is going to solve all your problems? No, it doesn't mean that. It means it has a place. The question is, where is it in your data center? And that's where we want to have a conversation with you and help you figure out exactly where it needs to fit and how we can make that successful. So I'm going to take a moment here and talk about success stories. But before I do have a Q&A slide at the end here. I'm going to pause just for a moment and ask our moderators, Sarah, do we have any questions in the chat session?
Currently, we do not have any questions in the chat.
Anybody have anything they want to ask? Please ask it now. And you can unmute or you can post your question in the chat. The moderator will read it and I will dive into it. Otherwise, I'm going to talk a moment about some success stories and show some cool stuff there. Otherwise, we'll move forward. Any questions? I've given plenty of time there for somebody to ask. All right, moving on. So, this example here, and this is in the slide deck. You guys will get the slide deck. This is being recorded for internal use in the future. For those that have attended, of course, you'll be able to get the recorded session if you so desire. But anyway, so in this particular case, this was a mobile phone company. I think most of you guys know we're not talking small companies here. This is 140 million users sitting on the system. And we actually wrote the software-defined store in this particular case, but this was a NAS solution. So we can take what's old and make new again. They were actually using an appliance, or a big 3-PAR in this case. So a big 3-PAR to compete against other vendors out there, in this case NetApp, because NetApp was tried, NetApp failed. Long story short, it couldn't scale to the levels that they needed it at 140 million simultaneous users. For those that don't understand file lock, file open, file descriptors, when you talk about manipulation of internal I/O, it creates a huge bottleneck in most controllers. And when you get into NAS solutions, there's a few on the planet that can handle something like that. That's what we did in the labs at HP. It's what I'm very good at and what my engineering team is very good at. We actually went in and actually built a large-scale service guard cluster that delivered this at 100. Right now, it's running about 110 million users, and it is one of the largest ones that we have in North America. Very proud of that. So very cool stuff. The other one would be taking a little over 4,500 servers and patching those servers. So in this particular case, BIOS and firmware was included. We did this about a year ago, and since then we've actually taken this and now we've actually automated the entire stack on top of that core OS. But this kind of gives you an idea of the complexities that we're talking about. So this again is, this system, this client was a big pharmaceutical company, 4,000 or 5,000 servers, 50 plus thousand VMs is big, and their biggest problem was patching that environment. And in patching that environment, it was taking them about 18 months. And it took them about, I don't remember the exact staff, I think it was around 13, 12, 14 staff members doing it. And it took them, again, about 18 months. When we were done, it took one person 4 months. Patched the entire environment. That's impressive. I think it's impressive. Not only now, what we're doing is we actually patch the entire operating system stack. So the BIOS to firmware go into the application, the OS, patch the OS. In this case, it was ESX. We can do the same on Hyper-V KVM. Again, name your favorite hypervisor. Maybe it's a bare metal machine. Sure, that's easy. That's table stakes. And then on the application is now what we're writing our automation for the application. That's not easy on the application layer. So, as you guys know, there's not just one application out there. So we're working right now on just strategic applications, and we're going to add more to our arsenal over time. But this is pretty cool. I thought that was pretty neat for you guys to see that. We do have some videos that when you get this slide deck later, you'll be able to watch the slide deck and then click the videos and see exactly what we're talking about. The one in the middle, automation at scale, is a video that actually articulates the thousands of servers that we automated. Thought that was pretty cool for you guys to see that. We're not talking 7 servers here, we're talking thousands and thousands. Our current one we're doing is 65,000 bare metal systems. So what we do as an engineering firm, when we are automating that level of system, 65,000 systems, we take our intellectual property we've done there and we scale it way down so that we can deliver a differentiated experience to our commercial size customers that have 10 servers, 20 servers, 100. So we can take what we did at scale it down, and give that experience to our customers. And that's what we're after. So that concludes our Datera software-defined block storage webinar. What I hope that you took away from this is iSCSI is a wave of the future. Ethernet is what you need to be looking at. Is fiber channel going away? No. Does fiber channel have a play? Yes. Is it for everybody? No, sir. It is not. Fiber channel is very, very expensive. It has not made much advancements since about 6 years ago. It's currently sitting at 32 gigabit. There's faster in the labs. I think they're running right now 64 gig in the lab for fiber channel, but it's not the core. It's not where it's going. Where it is going is in a software-defined ecosystem of Ethernet. Everything in our data center, in SereneIT private data center, is 200 gigabit Ethernet. We run some of the highest speed networks in the industry. We're cutting edge. We've just invested millions in our current data center. And we have 1,000 systems. We're writing an enormous amount of automation on almost every product in the industry for Hewlett-Packard. We even have tape, and I don't like tape, for those that know me. I never thought I'd have tape libraries. Got tape libraries. Why? Air gap. Got to have air gap. That's part of our MSP practice. I'm a big stickler on having air gap. So look, as good as we are security-wise, it's hard to compete with the person sitting in their mom's basement that's constantly coming after you. So you got to make sure you keep it very, very secure. And we're doing everything we can to make that possible. And putting in air gap analysis, you got to do that. Speaking of air gap, imagine your software-defined block having a replication with an air gap built into it. That's what we do. We've got several clients already doing that. And how do we do the air gap there? We're actually writing the automation into the network layer. And we're literally segmenting off the block store for almost 18 hours a day. That is completely isolated. 100% air gap. Bring it back on, synchronize, split it back off. There is a problem with that. You got to buy two. Got to have redundancy. Got to have two of them. So the bald-headed man in the movie Contact comes back to us, right? For those that hadn't seen that movie, he says, "Why buy one when you can buy two at twice the price?" If you haven't seen that movie, I suggest you watch it. It's a great old movie. It's called Contact. Anyway, so let me stop for a moment and ask Sarah or Meenal, any of our moderators, do we have any questions?
No questions currently posted in the chat box. If anyone does have a question, please feel free to unmute yourself and ask Greg directly.
Greg, this is Bob McBroom. Do you have any thoughts on how products like Nebulon fit into the software-defined storage of the future?
Yeah, so Nebulon, I'm a little familiar with it. So give me a use case for Nebulon. Because right now I'm having a hard time finding a good use case for Nebulon.
Yeah,
give me an idea. What would you use it?
That's why I was wondering how, where if you had, any ideas on where this fits into the ecosystem. I haven't.
So right now, I don't have a good use case for Nebulon. It's a great new way of thinking on storage on the software-defined ecosystem. I like the concept, but with the market the way it is today in that space, we have already some forward-thinking companies that have been at it for a number of years. Datera is one of them. People know Scale.io, the EMC product, which is vPlex. I think it's called PowerFlex now. I'm pretty confident they rebranded it. So you got that as your core, what I would classify as your two powerhouses. Datera has a lot more features. It's self-service portal, RESTful API integration, telemetry data. So from an automation firm trying to give our clients a better user experience, right? Datera is best in class. Period. It's got more features.
I'm thinking this just lays underneath the management layer. This is, becomes part of the hardware layer. And
yeah, I just need to research it more and figure out where it has a play. I don't really know, because most customers right now from a management layer, you're more concerned with the CMP layer, and that's going to be CloudBolt or Morpheus. There's several others out there. I have my favorites, CloudBolt and Morpheus. Each have their pros and cons, but again, there's several others. So that's, I guess, where I'm having a hard time with it is understanding where it fits. But I would, maybe Bob, you and I can have more conversations with the manufacturer and figure that out.
Yep, sounds good. All right, I didn't want to get on a sidetrack on that, but just I was thinking out loud while.
It's a great question, dude. No, it's a great question. Great question. Anybody else? Yeah, dead silence. Nobody's got a question. I'm trying to think of another question. Bob, you got another one? Throw me another one.
Not at the moment. No.
All right. So I guess the last question I would have is for those that are not familiar with iSCSI. I will say most of the large enterprise customers that we work with, when you say iSCSI, they all cringe. Why? It's because they remember how iSCSI was and how iSCSI was difficult to manage 10 years ago. They remember that stigmatism and it stuck with them. They got burned for any number of reasons, especially in iSCSI. Remember the tow cards, TCP offload engines? Oh my. Just a rough beginning. That is not iSCSI today, period. iSCSI today is easier than Fiber Channel. You want a multipath IO driver? It literally acts and looks just like Fiber Channel. So what I would encourage you to do is stop thinking, it ain't Fiber Channel, I need Fiber Channel. You don't want to think that no more. You want to think, I want a modern block. How do I best achieve it? And how do I keep my cost constraints down? And how do I get the best in class performance? If I told you your performance on iSCSI would be faster than any Fiber Channel array, you'd probably say, I'm crazy. Not. iSCSI is faster. So I need you guys to be thinking that way. And, hey, you know what? Call us. We'll set up a demo. We'll show you. And I'll give you a Fiber Channel array and show it. In our lab, you can see it. So we can show our lab, we can show HP lab, we can show you the difference. There is a reason for a block storage appliance like a Primera array. I'm not saying there's not. Okay? I'm saying be thinking about the future of how they work better together. Okay, Bob, any final comments?
Oh, nothing for me. Thank you. It was very, very enlightening.
Well, I hope you guys took away something from this. I would love for you guys to reach out to us and ask us to do another engagement with respect to software-defined block, and we can show you more details of it. This webinar was intended to spur thought, inspire the next. With that, I turn it back over to our moderator. Sarah?
A few closing remarks. Again, thank you for attending this webinar. We'll be sending out the gift cards over the next few days. And like Greg said, if you have any questions or follow-up around what we discussed today, we would be more than happy to schedule a talk so we can talk one-on-one. Again, thank you for attending.
Thanks, guys. Y'all have a great day.